So welcome to lecture 5 for Intro to Backend Development. This week we'll be finally starting to not write code and start deploying our code to servers so other people can use our code. And this is going to be a two-part series. And the first part of it is going to be called Containerization. So before we get started for today, there's a few announcements to be made. PA3 grades are released this morning. This has been the case with PA1 and PA2 as well, but we'll be releasing grades every Monday if we can. And a lot of the time you'll have attached comments with useful feedback, so make sure you look at those if you haven't seen them for this PA or previous ones. And as usual, PA4 is due this Wednesday. Again, if you need help, you're free to come to office hours, and they're posted on Ed and on the syllabus. Okay, we're still getting a few people coming in. So okay, let's talk about what we've covered so far in this course. So we've covered REST, we've covered databases, relational databases, and abstractions. Again, this is kind of how to build a core backend. And starting this week, we'll be talking about containerization and this thing called DevOps. So this will allow us to deploy our code to the internet so that iPhones can connect to it, your other people's devices connect to it, and so on. So quickly some review of what we've covered last week. So we covered ORMs, and ORMs is the concept of using objects and classes to interact with a database. Rather than using raw SQL, we'll be using Python to interact with our database. And honestly, I know a lot of people prefer ORMs. There's some people that prefer SQL still over ORMs, but I think one thing that really appeals to me about ORMs is that when we're making relationships, right, we don't have to do the getting the foreign key and then getting the transaction from using that foreign key and so on. We can just do something like user.transactions, which is so much more convenient. And it reduces the number of errors we're going to end up getting. So if you haven't started PA4 yet, I assure you it's going to be easier than PA3. Cool. Is that clear? Is that clear from last lecture? Does that all make sense? ORMs. Are we good? Okay. Now let's talk about deployment. So deployment is the idea, right? Right now, all our code is on our local computers. And we can hit the endpoints using Postman on our browser, but if, say, we want to connect to it from our phones or connect other people's devices to it, we can't do that yet. So the idea of making that available is called deployment. So before we talk about the actual steps in deployment, I want to make two things clear. So there's this thing called environments, right? We've been using virtual environments this entire class. And there's two distinct environments that we have to note and keep in mind. So there's a dev environment, and then there's a prod environment. The dev environment is the code base that we actually work on. This is short for development, and it's usually pretty messy. It has test cases, it has print statements for debugging help, it has all that. Whereas the prod code base, or environment, is the code base that your consumers and your customers are going to be interacting with. So this has to be print statements free, it has to be style, it has to have good style. It basically has to be the most sleek and quick it can be so that our consumers have a good time using our code. Okay, so that's what dev and prod means. So now let's talk about the four-part process of actually deploying a server. So the first two steps is what we're going to cover today, and is under the umbrella term containerization. So we have to compress code into a production environment. So this is the prod environment that we just talked about. And we have to prepare this production environment to be run ready. So this means, for example, in the context of our app, it's pip installing our requirements, right? And a lot of the time you're going to have more setup than just pip install requirements, but that's basically what the first two mean. So the first thing, right, is to make our code clear, make our code clean so that our consumers are going to have a good time interacting with it. And the second thing is to make sure that our setup stuff is all done. And we'll talk about 3 and 4 next week. Well, after spring break. Okay, so again, the main question that this boils down to is how do we run our apps on other machines? Right now, again, all our servers are hosted on our local computers on local hosts. So how do we make it accessible for others to use? So first, I want to address why we would even want to do such a thing in the first place, right? So let's say we have a company like Google. Now, if Google has one computer and one computer only that has the code base, right? That's obviously not going to work, right? You don't get employees just like taking turns on the computer, being like, hey, your hour's up, my turn now. And that's not how it works, right? We want to be able to share our code efficiently and easily. And in production, obviously, we don't want our apps to be running off our local machines for several reasons. One of them is that if I say close my lid, I don't want my entire app to crash, right? If Eatery was hosted on this computer and I shut the laptop, we don't want the entire Eatery to go down. And the second reason, security reasons, right? We don't want people accessing our IP, but that's not necessarily too important. The idea is that we have to be hosting it elsewhere on a server, which is one, more powerful and two, more reliable. So that's what we're going to be talking about today. So again, environments. We have the prod environment and we have the dev environment. What is even in an environment in the first place? So let's talk about it. So there's four things in an environment, right? There's an operating system, right? So a lot of you have Macs, a lot of you have Windows. That's one of the things. The second thing is your code, right? So in this class's context, it was app.py and db.py. We have our libraries, so this is everything listed in requirements.txt. And then we have these things called environment variables. So again, right, we have our operating systems, our code, our libraries, and environment variables. So, just to clarify, we're going to cover what environment variables are, just for those of you who aren't particularly familiar with that yet. So, what are environment variables? Environment variables are strings or pieces of text that you don't want actually present in your code when you say deploy it to, or put it to GitHub, or upload it elsewhere on a bucket service. The reason why we don't want such, we have such a thing called environment variables is because, for example, SQLite 3 is a database, right? Postgres is also another type of database, but to use Postgres, we actually have to log in to Postgres to use it. So that means having a username, and it means having a password. Now, do we want our username and our password to be publicly visible on GitHub? Obviously not. So our workaround for that is this thing called environment variables. Environment variables are usually stored in a file called .env, and just because you don't want it on GitHub or any kind of anything on the internet, you would log into your server and make that same env file. That way, it's actually never on the cloud. It's always on your computer or on the server's computer. Okay. So here's a little example, right? Postgres. I'm trying to connect to Postgres. Our host is localhost. Maybe our database name is Ithaca Transit, so I'm working on Transit right now. My username is SN685, and my password is super secure password. Now, we don't want people actually seeing this on the internet, right? So what we can do is create this thing called an env file, where we actually list out all of the values that we need, right? So the variable database has Ithaca Transit, the variable username has SN685, the variable password has my extremely secure password, and so on. With that done, right, in our code, we can actually just use the environment variables as such. So you can do os.environ for environment and access our environment variables that way. By doing this, we don't actually expose any of our secret values, our passwords, our things called API keys. We don't expose any of that. And this ensures that no one actually has forbidden access to our resources. Again, a .env file lives only in your computer and only in your server. So you never actually upload it to the internet. So the way you do this is pretty manual. You have to go into your computer, make an env file during dev, and then go into your server and make the exact same env file, and that way it's actually never stored on the internet. Cool. Does this make sense? All right, 4 parts in an environment. Right? OS, code, libraries, and environment variables. Awesome. All right. So far in our class, what have we been doing? We've been having a very, very small scale approach, right? Hate to break it to y'all, but our apps are very, very minuscule in the world that we live in today. So all we do is install Python 3, install requirements.txt, and run app.py. That's all we do, right? And this works well for simple applications. It's only a 3-step process. But you guys already know from lecture 1 how much of a headache it was to set up virtual environments, right? We all remember that. And imagine having a larger application, say like you're working on Google Maps or something, and you have to requirements install for Python and install NPM and Node and all that. TLDR, it becomes really, really cumbersome and a lot of setup stuff that you really don't want to deal with because it's very, it's a big headache, and if you mess something up, you're just going to mess up the whole thing, the whole setup. So we want a very modular and simple approach to solving a problem like this. So the old way we used to do it, I'll just quickly go over this, is called virtualization. So what is virtualization? Raise a hand, show of hands. Who has used a VM before in this class? Okay, so quite a handful of you. A VM, short for virtual machine, is essentially running another computer within your computer. So on Macs, you can actually run this thing called Boot Camp and run Windows, a Windows operating system on it. It's very similar in that you're basically running a computer within a computer. Now let's look at this diagram, right? And a lot of kind of buzzwords that we don't really need to care about. But the main thing to note is that app A, app B, app 3, let's say those are 3 different apps that we're working on. They all run on their own virtual machines, right? So it's like having app A run on this, and app B run on that, and app C run on that. That is very, very resource inefficient, and it's also really slow. So what is our solution to this? Our solution is this thing called containerization, which is what we're going to cover today. So again, just to quickly reiterate, right, containerization covers the first two steps of deployment, being to compress code into a production environment and to prepare a production environment to be run ready. Okay, awesome. So let's talk about the first step, compressing code into a production environment. Step 1, clean up your code. Okay, this is kind of a meme slide, but also kind of not, because it's actually really important when it comes to preparing your app for the production environment. The reason why this class has been very strict with you in terms of style, in terms of having unnecessary print statements or code or comments or whatever, is because we want you to have good and clean and slick code when it comes to making apps in the real world, right? Print statements are nice for debugging, but they clutter up your terminal. They are slow to run. It's just not very pleasant to have in a production environment. So the first step is to clean up your code, right? All the style issues that we've addressed so far in this course. Cool. Let's talk about the second step, the actual step. Step 2, Docker. So Docker is a very popular service, and is essentially the crux of what we're going to be covering today. And it allows you to neatly package all our environment, so again, our OS, right, our code, our libraries, our environment variables, all into this neat standard unit of software. So it's like packaging everything into a little container, and that container can be passed around on different devices and can be run on different devices. So for example, again, going back to the Google Maps analogy, if let's say Google Maps has like 50 setup steps, and we don't want to deal with it, well then someone can just make a Docker entity and upload it to the cloud. We can just pull that and then run it smoothly on our computer. So it has the entire environment just compressed into this little container for us. So that's what Docker is. Okay, Docker images. What are Docker images? Docker images are what we build from our code. So if we have something like our code, our OS, our environment variables, blah, 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 we construct something called a Docker image. And a Docker image is, you can think of it as a blueprint for actually running our app, right? Our instruction set, our blueprint, whatever you'd like to call it. And it's defined, the behavior of a Docker image is defined with a file called Dockerfile with no extensions. So Kate will cover that in a sec during demo. That's what Docker images are. They're blueprints for your app. Docker containers, on the other hand, are live instances of your app. So again, right, if I download a Docker image of Google Maps, I will run it and I'll make a container out of it, and the container will be what's actually running, right? So you know what we've covered so far in the course, we run python app.py. If we run python app.py in the context of Docker, that'll be running in a Docker container. Okay, hopefully that makes sense. So images are to containers as classes are to objects, right? For those of you who have taken object-to-object programming, that might be familiar to you, or blueprints and houses, or recipes and cakes, or recipes to production of these instructions as to production of these instructions. So again, images are the blueprint and containers are the live instances of our app that we build out of those blueprints. Okay, again, another little diagram, right? So if you can see here now that each of our apps have this kind of Docker kind of layer under it, right? Instead of having a virtual machine dedicated for each of our apps, we have one operating system, one computer that has Docker installed and runs all our apps seamlessly. So this is what makes Docker so nice, is that it makes things so modular and simple for us to use. Okay, benefits of using Docker. Well, hopefully this is already pretty clear, but the main thing is simplification and modularity. So we don't have to be running all our steps, right? If someone doesn't know how to run our Python app, we don't need to tell them, hey, you have to install Python 3.8, and then you have to pip install this, and then run app.py when you're in the actual directory and all that. We can just run the Docker container on our machines. Also, one thing to note is Docker containers are very, very, very minimalistic. They have basically nothing but essentials to run your app. This makes it so that it's very, very resource efficient, right? And yeah, that's just one thing to know about Docker containers, is that unlike your computer, which probably has like, you know, my Mac has like an iMovie and like all this Chrome and all this garbage. Like we don't need all that in our Docker containers. Okay, second step of preparing our production environment to be run ready. Again, it's all the setup stuff that we mentioned. So in our case, just pip install, but in larger scale applications, a lot more. Okay, Docker Hub. What is Docker Hub? Let's see, who here has used GitHub before or is familiar with GitHub? Okay, that's the vast majority of you. Great. So, you know how you store code on GitHub, right? You push code onto GitHub and it stays there. Docker Hub is essentially the same thing, except instead of pushing code, you push your Docker images. Again, Docker images being the blueprints, right, of your app. So, Docker Hub is where, again, we push our images, and once those images are pushed, right, push being basically upload, other computers can pull our image or download our image and run our app seamlessly there. That's what Docker Hub is. Okay, so here's the workflow of Docker. So again, we create a Dockerfile, right? This defines how we actually want to be running our app. We build an image out of the Dockerfile, so a blueprint on how to run our app, how to set up our app, all that stuff. And then we push our image to Docker Hub. One thing you might notice here is that we don't actually build a container, but again, that's because a container is a live instance of our app, and like, you know, we don't really need to run the live instance of our app on our local machine for us to be able to like deploy it, right? We just have to like push our code and then pull it from the server. That's why container isn't actually on here. Then we pull the image on our server. Our server, again, is another computer, essentially. And then so we can pull the image and run the container live instance on the actual server machine. Okay, hopefully that's not too many buzzwords. Does that make sense? Does anyone have any questions so far? Are you good? Okay, awesome. So there's a few reasons why, well, there's one reason why I have so many whales drawn here. Very cute whales, Docker whales, love them. But there's a reason why we have so many drawn here. And that's because one app can actually have a bunch of containers running at once. So let's think, right? Let's go to Ithaca Transit because that's what we actually developed instead of Google Maps. Ithaca Transit, right? It has a map view, right? How do we display the map to our users? It has calculation of times, right? From destination or from point A to point B. How long does it take to get there? It has all these things, all these little services that kind of all contribute to the app, right? So if you look at Ithaca Transit, it's not a simple app at all. There's a bunch of things running at once. And so you can have similarly, you can have a lot of containers running at once. So how do we actually run a bunch of containers if we have an app as complicated as Ithaca Transit, where we have a bunch of services running at the same time? Well, that can be done by this thing called Docker Compose. Another very cute animal, octopus this time. Using Docker Compose, we can define how to run multi-container apps. For now, for this course, we'll just be working with one container. But essentially what Docker Compose allows you to do is define how to run each container and on what port and that kind of jazz. So yeah. So again, a little depiction, right? Docker Compose can kind of hold a bunch of containers at once and instruct Docker how to run them. Yes, question?
Wait, so is each container like an individual virtual machine? Or?
Okay, so it's not a virtual machine. A virtual machine, again, is a computer within like a computer, right? So it's like having, apps run on like all of our different devices and like having one central device that like kind of collects information from each of them. So that's what virtual machines are. Containers are these little neatly packaged, super small and compact contained environments, and it can all run on one machine, unlike having virtual machines for like each of our apps. Okay, so that's what makes it modular and much more simple and less resource inefficient. Okay, does that make sense? Awesome. Okay, so to summarize what we covered today, we have to first define a Dockerfile to specify our app's required environment. So in the Dockerfile, we'll actually be showing you shortly in demo, but it'll have things like install Python 3.7 and pip install everything, and then run python app.py. So all that stuff will be defined in our Dockerfile. Then we'll build a Docker image, right? So the Docker image is basically a blueprint of how to run our app and how to actually construct it. Then we'll push the image to Docker Hub so that other people can actually access it. And then in Docker Compose, we'll define how to run each of our images as containers. Okay. I think that's it for demo, or for lecture. Or no, actually there's one more thing. Okay. So all this Docker stuff and deployment stuff falls under the hood of a term known as DevOps, short for Development Operations. So kind of like low-key, this is a field in its own, right? Kind of separate from Backend, but it's the study of shipping software fast. So as we're developing software, right, which is what we've been doing, we've been writing code. DevOps is the process of testing our code and then releasing it for the public to use. Again, so far we've only had our local machines be able to run our code, but we want to make it so that the public can use our code as well. So the process of doing that is called DevOps. But honestly, it kind of, the definitions kind of enter like a little gray area, because like we should be testing our code simultaneously as we write our code. Okay, so here's a little chart or diagram of what DevOps is. And this isn't particularly a topic we deep dive into in this class, but a lot of people enjoy DevOps, sometimes even more than backend development on its own. So you can look into that if you're interested. But yeah, that'll be it for lecture. Before I let Kate do demo today, you guys should all go to the course textbook, go to the pre-class to-dos, and try to install Docker. I think Windows has a slightly better version of Docker available to be used now. But in previous semesters, Windows and Docker was not particularly compatible. So you have to install a separate virtual machine and run it on there. But yeah, while we wait, I guess, please try to install Docker on your computers so you can follow along on Kate's demo.
Okay, cool. So yeah, everyone should go to the course textbook and then go to like containerization and then pre-class to-dos. And then can see how to install Docker on here, and it links all the installation packages you need and stuff. And make sure to also create an account on Docker Hub. So yeah, I'll just continue giving y'all some time to do that because I know it takes a while. And then once you have it installed, make sure you like open Docker, because this sort of runs, the Docker app kind of runs in the background of everything and like sort of does what it needs to do. And yeah, so make sure you have this open or else the process of Docker won't run. And yeah, if you have any questions, feel free to just raise your hand and someone will come help you. But can everyone like raise their hand when they're done, or give a thumbs up or something when they're done installing? Okay, so I see a few, but I don't see a lot. So I'll just give you all, I guess, 3 more minutes maybe. And then also if you have everything like installed already and like the Docker open, make sure to also open up the demo from last time. We're just going to be working on containerizing this app. And make sure you have your terminal open. Let me just make this bigger. Oh, you have a question?
Is there a downloadable version of the demo?
So there's like a demo for starter code that's also linked in the installation page, but it only has the hello world endpoint. So if you did take, like copy down the demo from last time, you can use that. Otherwise, you're free to just containerize a bare bone app that just returns hello world.
Yeah. So we're not actually going to be coding new routes today. We're just going to be working on actually creating the container. We're building an image and then creating a container off of that. So as long as you have sort of a working backend, that's all you really need. But we're just going to use demo 4 on this one. And can everyone like give another thumbs up if you have everything installed? Okay, I see more now, so I'm just going to continue. But yeah, if you have any issues or run into any issues, feel free to just raise your hand. But the first thing we're going to do is create, where we're just going to test our code to make sure everything works. So I'm going to activate my virtual environment and then just hit some endpoints. Oh, oops. Okay. So yeah, I'm in my virtual environment now. So I'm going to go to Postman and then I'll just get all tasks. Oh, I forgot to run the app. And yeah, I have get all tasks. I can. Oh, okay. Okay. And then I can create a task. I can get specific tasks. And yeah, all my endpoints seem to be working fine. So I'm going to work on actually containerizing this right now. Let me make this larger too. Okay, cool. So the first thing we're going to do is create that Dockerfile, which basically tells the computer how we're going to run our server. So in our src folder, we're just going to create a new file called Dockerfile, and it's capital D, just Dockerfile, no like extensions. And you'll see this like whale pop up next to it, which is the Docker logo. And yeah, we're just going to create this. And then, so if you remember from PA1 or the demo one, to run your code, the first thing we need to do is actually install Python. And then we need to create sort of a working directory to put all our code in, and then yeah, copy all of it over, and then like run Python app.py. So we're in the Dockerfile, we're basically going to tell the computer to do the same thing. So the first thing we're going to do is sort of install Python in like this Docker file. So to do this, it's just going to be from Python 3.7. And this from indicates a base image. So this is the image we're building off of. So we're building off a Python image. And if you go to Google, you can actually search up Docker Python. And you can see that there's an official image for Python with different versions and everything. So this is the image that we're building off of, and we're creating a new image for our server from Python. So we're doing version 3.7, and then this sort of installs Python in the Docker container or Docker image. And then next, we're going to create a directory where all the code is. So we want to create a directory because we don't want all our like files just combined with all our system files. That just gets really messy. So in order to create a directory, we're going to use a command called run. And this basically just runs different commands. And the, I guess, command line command for creating a command, creating a directory is mkdir. And then we're just going to call it user app. And then next, we're going to set this as the working directory, which basically means that from here on out, everything we reference is going to be in respect to user app. So that's just WORKDIR, and then we're going to set it to user app. Yeah, so again, the from is basically sort of installing Python. And then this is creating a directory or folder to put like the app and db.py in. And this also just lets the computer know that we're going into this folder, and everything we do from here on out is going to be in sort of this folder. And then the next thing we want to do is take all the code in here and copy it over. So to do that, we're just going to do copy dot dot. And the dot, if you remember from the first, I think, demo, just means the current directory. So because the Dockerfile, I think, oh, it's not in here. So make sure to move your Dockerfile in the same sort of like folder as your app.py and db.py. And so the dot basically just copies everything in this directory in our SRC into this directory over here, user app. And then the next thing we're going to do is after we copy everything over, now we have a requirements.txt in this directory we just created. So we're going to run pip install requirements.txt like we always do when we have a virtual environment. So we're going to run another command, pip install our requirements.txt. And then the last command is a bit different. We're not going to use, I'm going to make this bigger. Oh, is this a good size for everyone? Okay, cool. So the last command we're going to do in our Dockerfile is a bit different. Even though it's technically a command, we're not going to use run, we're going to use cmd. And this cmd, you should only have one in your Dockerfile, and I think you can only have one in your Dockerfile. But basically, it just tells the computer how you're going to run this app. So when we ran this, let me stop this real quick. We use Python, Python app.py. So the command to start the server is going to be Python app.py. So yeah, this is all we need in a Dockerfile. And usually we only have one of command and one base image and one working directory. And then, so if you ever in the future, probably for Hack Challenge, need to containerize your app, this is a very good sort of skeleton for how you're supposed to do it. Does anyone have any questions on how we created this and what everything means? Okay, cool. So now the computer knows sort of how to run our server in this container or image, which we use to build the container. So now we're going to actually build an image, which is the blueprint for which a container runs off of. So to do that, we're going to do just Docker build and then dot, which basically means we're going to build the current directory. And it's really important that your like Docker commands all go in the same file as your same like level as your Docker file. So let's say we were in a parent folder for this, and then we ran like Docker build, you would get an error because you can't find the Docker file. So make sure you're in the same level / folder as your Docker file. So I'm going to do a Docker build dot, and then you'll see all of this in your terminal, which basically means we're building the image. So it's running everything we sort of declared in our Docker file. It's first loading the Docker, the base image, and then like running like the WORKDIR user app / creating the directory, and then copying everything over and then running the requirements, and then finally creating that image, which is again like the blueprint for which containers are built off of. Cool. So I'm going to make sure that all my images were built, where this image built correctly. So to do that, I can just do Docker images, and it shows me all the images I've sort of created / built since I last pruned it, which means like sort of cleared the history of this. So this is sort of just like stuff I've done in the past, but you can see that the Docker image we just built 38 seconds ago is here, and it's successfully created, and it has a size and everything. But if you notice, it doesn't have a repository where tagged like the other images down here do. So how do we sort of give it a repository and tag? So we're going to sort of alter our Docker build command a bit. We're going to do Docker build -t, and then we're going to sort of define the repository name. So I'm going to do my Docker Hub username /demo5. And then if you noticed when we ran Docker images, we don't have a repository where tag, which is not very good stylistically, because what if you had a bunch of images like this and you don't really know what this is for, and you have no idea why you just have this image here. So we're going to rebuild this image, and we're going to give it a name, so that name and tag, so that you have an idea of what this is doing. So to do that, we're going to do Docker build again, but this time we're going to do -t and give it a name. So this name is called like my Docker Hub username, which is KS Leong, and then the name I want to give this. So I'm just going to call this demo5, but you should probably replace this with your own Docker Hub username. And we'll go into why this is important when we like push this to Docker Hub, like probably on Wednesday, but yeah, make sure you do that. And then finally, we're just going to do dot to represent we're building this current directory. So when I do that, hopefully this one's quicker because you built this image once already. But once I do Docker images again, you can see I have a repository, a tag, and yeah, this is a lot more clear, and I sort of know what's going on, what this repository is when it's been made. And yeah, so more on Docker image tags. So image tags usually represent the version of your Docker image. So default, when you run like the -t, and it gives the tag as latest, but that might not be clear. So if you go to like the Python one, you can see they have a bunch of different tags that sort of show like what each one does. So this might be better. So if I wanted to make this even more clear, I can give it a date and to define, oh, if this moves. Okay, so to define a tag, I basically, after my repository name, I put a colon. Okay, my computer is being slightly slow right now, but I can give it a tag name. So I'm just going to give today's date as one. And then everything builds. And when I run Docker images, you can see I have sort of a different tag, and this is a bit clearer. And yeah, so that's it for today's demo. Hopefully you're able to build a Docker image, give it a name, and next time we'll sort of go into running this image / building container off of it and pushing it to Docker Hub. But yeah, we're gonna start the